Hello everyone. Welcome to the part 2 of the Mastery of the Derivative Using Power Rule series. If you have not watched the first part of the series, I recommend that you watch that part. Okay, this is the second part, and watching the first part will greatly help you understand this set of exercises that I'm gonna show you. Okay, so let's go ahead and jump right into question number 16. So find the derivative of this expression given here. So using the power rule, okay, so what we do is multiply this negative 4 times 4. We got negative 16x. Now take away 1 from that minus 4, so we got negative 5. The negative 3 times 3 is negative 9x to the negative 3 minus 1 is negative 4. And the negative 2 times 2 is negative 4. X to the negative 2 minus 1 is negative 3. Now the exponent negative 1 times negative 1 understood. Okay, so that's going to give us positive 1. X to the negative 1 minus 1 is negative 2. Okay, so you can leave your answer this way, or if you want, you can move all those variables x, okay, below, and by the use of the property of exponent, when you move this, you have to switch the sign of the exponent. So now we have x to the fifth and the negative 9. So move this variable x downstairs. Now we have x to the fourth. Negative 4 over this x becomes x cubed, and then plus 1. So that positive 1 is now the numerator by itself, and then over x squared. Okay, that's how you get the derivative for our number 16. Okay, let's suppose number 17 is 3 over x to the fourth minus 4x to the third plus x to the negative 2 over 4, then minus 2 over x. Okay, I'm going to add 7x here just to make sure we remember, okay, how to get the derivative of those simple terms. Okay, so the reciprocal. So this is a reciprocal, if you remember, and we have a shortcut for those types of expression, right? Okay, so what is the shortcut for our reciprocals? So we get the derivative, so we say prime, okay? So the derivative of this reciprocal, so what we do is multiply 3 and 4, we got 12, over x to the 4 plus 1, 5, and then make sure you switch the sign, okay? We know it's a reciprocal because we have a constant on top and then variable x in the denominator. Now for negative 4, x to the negative 3, okay, that's simple power rule. That's negative 3 times negative 4 is positive 12. And then x to the negative 3 minus 1, negative 4. Okay, now here it's understood to be 1 times. So that's negative 2 x to the negative 2 minus 1, which is negative 3 over 4. Okay, now this is another reciprocal right here. We have a constant on top and then variable x in the denominator. So we can multiply 2 and 1. That's a 2 over x raised to 1 plus 1 squared. Then we switch the sign. All right, so this 7x, its derivative is just the 7, and then the constant, the derivative is 0, okay? All right, so we are done. We just have to clean up. That's 12. If you want to move the x down here, just make sure you switch the sign. Now 2 and 4 is reduced to 1/2. Also, you can move the x to the negative 3 down. So we get 1 over 2 x cubed, and then plus 2 over x squared plus 7. All right. Number 18. Let's say we have to get the derivative of, say, 2x minus 3 to the 0. Okay, so the derivative of, okay, the derivative of 2x minus 3 to the 0. Now, we know that 2x minus 3 raised to 0 is going to be 1, okay? So the derivative of constant is just going to be 0. 1 is a constant, okay? Number 9, let's say, go ahead and find the derivative of 2x minus 3 to the first power. Okay, so I'll be continuously increasing the exponent. Now, 2x minus 3 to the first is just 2x minus 3, okay? In other words, the derivative is simply 2 minus 0, or just 2, okay? Number 20, go ahead and find the derivative. What happened if I increase this 2x minus 3 now raised to the second power? Okay, how do we use the power rule? Okay, later on, I'll be posting another video for the second rule of the derivative, which is product rule, okay? Also chain rule. Now for this video, I promise that I'll be only using the power rule. So in order for us to use the power rule, then we have to use algebra here as our initial step, meaning we have to expand to x minus 3. And expanding that means multiply 2x minus 3 times 2x minus 3, which is 4x squared minus, okay, so you can FOIL out 2x minus 3 times 2x minus 3, and you're going to get negative 12x plus 9, okay? So what we did, we used the algebra initially, and then once we expand it, then we can now go back to our power rule, which is 8x minus 12. Okay, so again, later on, I'll show you how to do it by either product rule or by chain rule, okay? But if you want to stick to power rule, this is the way to do it. Okay, number 21. How about if you have to find the derivative of 2x minus 3 to the third? Okay, I know it's not going to be easy to multiply 2x minus 3 by itself 3 times. Okay, it's a very tedious process of doing it. But in order to use the power rule, okay, you really have to expand it. Now, we have a way to simplify 2x minus 3 to the third without doing this kind of distribution, okay? So what we can do is use this kind of like shortcut to expand it, okay, by starting with the 2x. I had a separate video on how to expand binomial, okay? And this is done this way. Start with the 2x and raise to the third, okay? And continue doing that by reducing the exponent, okay? 2x to the second, and then 2x to the first, and then 2x to the 0. Okay, after taking care of the 2x, you go to the 3, okay? But this time you reverse the process of raising the exponent. Okay, you start from 0 this time and all the way to the third, okay? Now the coefficient, okay, you always begin with 1, and there's like a symmetry. If the first the first coefficient is going to be 1 all the time, okay? Now so is the last coefficient. Now to get this coefficient here, what we do is multiply 1 times 3, and then you divide it by this exponent, but add 1, okay? So that will be 3 over 1, which is 3. Now to get this next coefficient, we multiply this 3 and 2, and then you divide it by what? Divide it by 1, but add 1. So that's 6 over 2, which is 3. So you can see there's like a symmetry. The first one and the last one, are the same. And the second term and the second to the last coefficient are the same, okay? So we just need to simplify this. Now 3 to the 0 is 1. Now 2x to the third is 8x cubed. Okay, by the way, if you're expanding a difference of this binomial, then you want to make sure that the signs alternate. So starting from positive, then negative, then positive, then negative, okay? Again, I had a separate video on how to expand binomial. So if you want to watch that, you can just look for binomial expansion shortcut, okay? So this one here is 3 times 3, which is a 9. But 2x squared is 4x squared. So 3 times 3 is 9 times 4 is going to give you 36x squared. And then right here we have 9. Now 3 and 2 is 6. Okay. So 9 times 6 is positive 54x. Now this 2x to the 0 is 1. 3 to the third is 27. So minus 27. Okay. Now you can start differentiating this using the power rule. So you have 24x squared minus 72x plus 54, okay? So you can see that in order to use the power rule, okay, you have to do the algebra first by expanding the binomial. Later on, you can use a different rule shorter than this way, okay? You can use a chain rule in order to find the derivative, and that chain rule is like a shortcut to get here, okay? So right now it's exclusively power rule. All right, let's go look at question number 22. Now this one is even more complicated because what I'm going to do is I'm going to raise the 2x minus 3 to the fourth power, okay? So this is like a review of binomial expansion. So let's go ahead and do the algebra first by expanding the 2x minus 3 to the fourth power. Again, what we're doing is like a shortcut of multiplying 2x minus 3 by itself 4 times, okay? Because it's raised to the fourth. So you multiply the 2x minus 3 by itself 4 times, and I'm showing you a different technique instead of doing this, standard distribution or foiling out. So again, just like what I did in problem 21, I started with with 2x, and then raised to the fourth, and then raised to the third, and raised to the second power, okay, raised to the first, and then raised to the 0. And then, okay, don't worry about the minus yet. Just write down the 3 and raise to the 0, okay, reverse to the 1, squared, cube, and then fourth. Okay, now let's take care of the coefficient. I mentioned earlier that the first one and the last one are always 1, okay? And the signs are going to alternate because it's a minus. So this is a positive, and then negative, and then positive, and then negative, and then positive. Okay, so how you get this number here? How do you get this coefficient of our second term? So what you do is multiply 1 times 4 divided by what? 0 plus 1. So 4 over 1 is 4. Now we know that because there's a symmetry here of the coefficients, if the second term is 4, the second to the last term is going to be 4 also. Okay? So let's go do this middle term here. So to get the middle term, we multiply what? 4 times 3 divided by what? 1, but add 1 all the time. Okay? So 12 over 2 is 6. Now just to double check, because we know it's already 4. But again, You can double check by multiplying 6 times 2 divided by what? 2 plus 1. So that's 12 over 3, which is 4. All right, so that's the expansion of the binomial. So 2x to the fourth is going to be 16x to the fourth. Okay, minus, probably need a calculator here. This is 8, okay? 8x cubed. Now 8 times 4 is 32. See, this 2 to the third is 8 times 4 is 32 times 3 is 96x cubed. Okay, how about this one? This is 4x squared. Now 3 squared is 9, okay? So 4 times 9 is 36, and then multiplied by 6. So that's 216. So positive 216x squared. Okay, minus, now this is 27. 27 times 2. 27 times 2 is 54. And then 54 times 4 is 216 also. So 216x. Okay, plus. Okay, plus the last term. Now this is raised to the 0. So we know it's going to be equal to 1. 3 to the fourth is 81. Okay. So this is the one we're going to differentiate using power rule. Because now we have this individual term where we can apply the power rule, okay? 4 times 16 is 64 x cubed minus, okay, 96 times 3 is, I believe it's 288x squared plus 216 times 2 is 432x minus 216. There you go. That's the derivative. All right. Let's look at number 23. Okay, let's focus now on square roots. Okay, so what is the derivative of the square root of x? Now, I gave you the shortcut from the previous video involving derivative of square root of x. Okay, and this is something we have to memorize because this will come up very often. So the square root of x, its derivative is always 1 over 2, the square root of x. Okay, if you don't memorize, it's just going to be tedious to really show the step-by-step process. Okay, I'm going to show it to you using the long way. So first thing you do is, if you don't use the shortcut, is to express this using rational exponent, meaning this is equivalent to what? X raised to 1 over 2. And then you get the derivative. So using the power rule, it's going to be what? 1/2 times x raised to 1/2 minus 1. That minus 1 in the form of 2 over 2. So that is what? 1/2 x to the negative 1/2. And then you move it down, which is 1 over 2 x to the 1/2. And then you write it back in radical form, which is 2 square root of x. So you can see how long the process will be if you don't use the shortcut. You just have to remember or memorize this. See? The square root of x is always 1 over 2 square root of x. Okay, so let's see it again. Let's say 24. Let's say you have to differentiate 2 square root of x. Let's say there's a coefficient here, okay? Now you can, you can express this as 2 times square root of x, 2 being a constant. is going to be 2 multiplied by, okay, so the shortcut for that is what? 1 over 2 square root of x. All right, so there you go. It's 1 over square root of x. See how easy it will be if you apply the shortcut to find the derivative of the square root of x. Okay, this constant, all you need to do is bring it down, okay? Let's see it again, number 25. Let's say you have a fraction 3/4 next to the square root of x. All right, so again, this is just 3/4 times the square root of x. Now, 3/4 is a constant coefficient, okay? So when you start finding the derivative, you just bring it down and then apply the shortcut for that square root of x, which is 1 over 2 square root of x. You just need to simplify this into 3 over what? 8 square root of x. Very easy. Okay, how about if we have a different index? Let's say you have cube root of x. Okay, for the cube root of x, we have to, okay, we have to express this using rational exponent. So to get the derivative, we have to raise this to 1/3, right? Because this is equivalent to x raised to 1 over 3. So when you get the derivative, it's going to be 1/3, because 1/3 times 1, okay, is 1/3 x raised to what? 1/3 minus 1. But that 1/3 minus 1 is the same as 1/3 minus 3 over 3, okay? I want to use this 3 as my fraction 3 over 3, which is 1. So that is 1/3 x to the negative 2/3, which is also 1/3. If I want to move this, if I want to move this down, then it's 1 over 3x to the 2/3, and that's it, okay? You can also express it in radical form, you know, that x, when you raise it 2/3 in its radical format, is the cube root of x squared, okay? So either you have this form or the radical form. Okay, let's look at number 26. How about if we have cube root of x squared prime? Okay, so again, express this in rational exponent. This is equivalent to x raised to what? To the 2/3, okay? So 2 over 3. So the derivative will be 2/3 times 1, and then x. So you see how I extend my bar? So you're very clear which one is the numerator and which one is your denominator. 2/3 minus 1, again in the form of 3 over 3. So that is 2 over 3 x to the negative 1/3. Then I can move this back. Here in the denominator now, it's 2 over 3 x to the 1/3. Now, in its radical form, it's 2 over 3. Okay. Now, x to the 1/3 is the same as what? Cube root of x to the 1, or simply x. Okay. How about, let's say you have 27. It's a combination of 3x to the 1/2 plus 4x to the 1/4 minus 3x to the 1/3. Okay, so emphasis, rational exponent. Get the derivative. So the derivative will be what? 1/2 times 3, okay? So 1/2 times 3, x to the 1/2 minus 1 or minus 2 over 2. Okay, plus 1/4 times 4, x to the 1/4 minus 1 in the form of 4 over 4, okay? And then minus what? 1/3 times 3, x to the 1/3 minus 1 in the form of 3 over 3. So 3 times 1/2, top to top, bottom to bottom, that's 3 over 2, x to the negative 1/2. Now 4 times 1/4 is just going to equal 1 plus x raised to what? Negative 3/4, okay? 1/4 minus 4/4 minus 1/3 times 3 is 1. X to the 1/3 minus 3 over 3 is negative 2/3. Okay, I'm just going to move those x with a negative exponent downstairs if I want to express them using positive exponent. So this is 3 over 2, x to the 1/2, plus, this numerator x. You can always write down the times 1. So when you move it move it down, you will have 1 on top, okay? X to the 3/4 minus, same here, times 1, minus 1 over x to the 2/3. Right? So there you go. The derivative of these terms with the rational exponent. Okay, let's look at 28. Now, we have a rational exponent here, but negative, okay? So, don't be scared with the negative exponent, especially if it's a negative fraction, okay? So, the derivative is equal to what? Negative 1/2 times 3, x to the negative 1/2 minus 1, which is minus 2 over 2. Okay, and then negative 1/4 times 4, x to the negative 1/4 minus 1, minus 4 over 4. This is negative 3/2. Now x to the negative 3/2, and then 4 times 1/4 is 1. So negative x to the negative 5/4 right here. You want to move this down here just to express it using positive exponent. It's negative 3 over 2x to the 3/2 minus, again, this is understood times 1. So minus 1 over x to the 5/4. Now, in its radical form, okay, in its radical form, that x to the 3/2 is square root of x cubed. Okay, so this is square root. This over 2 here is the index. Now, this can be simplified further because the exponent inside the radical is bigger than the index. So what we do is we can split the x cubed into x squared times x, and then extract the square root of the x squared, which is x, and then you will have that variable x that's going to stay inside the square root. Okay, so that part right here, you can replace that with this one. Okay, now same with the x to the 5/4. The x to the 5/4, that is the fourth root of x to the 5th. So I'm looking at this denominator now. You can rename that using radical, but you have to simplify further. So this 5 here is also bigger than that index. So how do we break it down? This x5, you can break it down into what? x4 times x. And the fourth root of x to the fourth is going to be x. And this x here is going to stay inside the fourth root, okay? Radical. So you want to rename this part here with this one. That's also another way to express your final answer, okay? So sorry about the mess, but hopefully you understand what I mean by renaming, okay? Now, let's look at number 29. Let's say we have to get the derivative of 2x to the 1/3 minus 3 square root of x plus 2 over square root of x. Okay, so combination of what? Rational exponent, there's a square root, and there's a square root of x, but the denominator. So let's see how we treat each one. So the 1/3, just multiply it by 2. Okay, so first we get the prime, meaning get the derivative. So 1/3 times 2, x raised to what? 1/3 minus 1 minus 3 over 3. Okay, the second term is negative 3. It's a constant, right? What's your shortcut for finding the derivative of square root of x? It's 1 over 2 square root of x. Okay, for this one, I need to rename it, okay, before I get the derivative, because your square root of x is at the bottom. So what you do is rename it as 2 over x to the 1/2, and then you have to move it up, okay, because you can only start the power rule once your x is numerator. So that is 2x to the negative 1/2, because you move it up. Then you can get the derivative of this by multiplying the negative 1/2 times 2, then x to the negative 1/2 minus 1, or minus 2 over 2. Okay? So cleaning this up, we have what? 2/3, that's 1/3 times 2, x to the negative 2/3. And then right here we have minus 3 over 2 square root of x. And then this will reduce to 1 minus x to the negative 3/2. Okay, so now we can just move this down, okay? So that's 2 over 3, x to the 2/3, minus 3 over 2, that stays the same. And then again, this is times 1, that's minus 1 over x raised now to positive 3/2. Okay, let's look at the last example. Let's say we have a similar one, okay? 2/3 of x to the 1/2 plus 4, but instead of square root, it's cube root. And then that same cube root of x is downstairs over here, okay? Now we have a shortcut for square root of x. I haven't shown you the shortcut for the cube root of x, so we'll just do the standard way to differentiate that. So this is, let's just rename it first, okay? So this is 2 over 3, x to the 1/2. I'm going to express everyone using rational exponent, x to the 1/3, okay? Because that's 1 over 3. Now this here is 2 over x to the 1/3. Okay, if I move it up. Okay, so there's no differentiation yet. It's just renaming algebra plus 4x to the 1/3. So this is minus 2 x to the negative 1/3. Okay, so this is just renaming. Now this is the actual derivative. 1/2 times 2/3 x to the 1/2 minus 1 plus 1/3 times 4 x to the 1/3 minus 1. Okay? Minus negative 1/3 times negative 2 x to the negative 1/3 minus 1. So this is 1 over 3. Okay, x to the negative 1/2. I'm just going to move it down automatically here to switch the sign to positive 1/2. Now this is 4/3, positive 4/3. 1/3 minus 3/3 is negative 2/3. So I'm going to move it down automatically here. Now positive 2/3. Okay, negative 1/3 and negative 2 is positive 2 over 3. And then raise this x to negative 4/3 and I move it down. Now it's x to the 4/3. Okay, that's the derivative for our last question. So stick around for the part 3 of this calculus power rule series. The part 3 is going to be the last stop for our mastery of the 50 questions, complete and comprehensive. Okay, and thank you for watching. See you on part 3.